Welcome to your Day 3 notes. We will be discussing inverse functions and relations, determining whether two functions or relations are inverses. So far we've been talking about how to determine what the inverse of a function is. We've also discussed composition in the lesson prior to that. So let's take a look here. We're talking about inverse functions. Two functions are inverse functions if and only if both of their compositions are the identity function. Okay, so what does that mean? Alright, so we have, remember this notation, f of g of x equals x, and g of f of x also equals x. Okay, so both of these compositions must equal x in order for the two functions to be inverse functions. Take a look at example 1. We're going to use the composition of functions to determine whether f and g are inverses. Okay, so step 1 is to show that f of g of x equals x. Okay, so basically what I'm going to do here is take function g and plug it into x for our f of x function here. Alright, I'll show you what I mean. So we have f of g of x equals, alright, so like I said, I'm going to take function g, plug it into x for our f of x function, so I will have 3/4 times, okay, this is where I insert g of x for x plus 24 over 3. Okay, and don't forget to subtract 6 as our f of x function states there. Okay, so next what I'm going to do here, notice that our 3's, right, are going to cancel out here. I have a 3 in the numerator, a 3 in the denominator, so those will cancel. So next I will have 4x plus 24 divided by 4, and once again, don't forget that minus 6. Alright, notice that 4 and 24 are both divisible by 4. Okay, so this works out nicely. We get x, because 4x divided by 4 is x, plus 6, right? 24 divided by 4 is 6. Then we have that minus 6, so I actually just end up getting x here, which is the result that I wanted. Alright, so we just showed that f of g of x equals x. Now we want to see, does g of f of x equal x? Okay, so g of f of x equals, alright, so here what I'm going to be doing is plugging f of x into x in our g of x equation. So what that's going to look like is I have 4, right, starting with my g of x equation. Now I'm inserting f of x, so 3/4 x minus 6. Okay, and then looking back at that g of x function, I add 24, and this is all being divided by 3. Alright, so I'm going to think about distributing that 4 to the 3/4 and the minus 6. So what that's going to look like. Okay, so 4 times 3/4 is just 3x. Okay, 4 times negative 6 is minus 24, plus 24, still over 3, minus 24 plus 24, those cancel each other out. So I have 3x divided by 3, which gets me x, which once again is our desired result. So here what we could write is since f of g of x equals g of f of x, and both of those equal x, that's how we know they are inverses. Okay, so that's kind of the conclusion that we want to come to here, given that we found that both f of g of x equals x and g of f of x equals x. Pause here to try example 2 by yourself. You'll be using composition of functions to determine whether f and g are inverses. Alright, so here hopefully you found that these are not inverses, and the reason for that, if you take a look, so if you first solved for f of g of x, you got 9x plus 6, and since that doesn't equal x, it cannot be an inverse. Then if you solved for g of f of x, you would have seen that you got 9x minus 6, once again not equal to x and not an inverse. Just want to make a note, if you had solved for one of these, so say f of g of x, and found that it did not equal x, that would be enough proof to show that these are not inverses, because even if g of x then equaled x, since f of g of x does not equal x, we do not have an inverse relationship there. If you have any questions about this, please bring them to class. Thank you.